This is the introduction to the normal distribution, or we also call the normal curve. Throughout this video, you do not need to take any notes. I just want you to listen, kind of understand what is normal distribution. And then in the next video, we're going to actually go through some practice problems, and that's when I'll want you to take some notes. So there are some characteristics of the normal distribution. I'm just going to kind of read through these. When the overall pattern of a large number of observations is so regular, we can describe it as a smooth curve. A family of distributions that describe how often a variable takes its values by areas under the curve. Normal curves are symmetric, which we also call bell curve. They are smoothed out histograms. So you're going to look below here at some vocabulary scores. And the mean, which we're going to talk about later in our examples, is the middle. And then you'll notice the values below are smaller, the values above are greater. And then there's this smooth curve of the scores. The total area under the normal curve is exactly 1, or 100%. Here are some examples of a normal curve and a not normal curve. So on the left, the first example, kind of see this histogram, that would be the curve. Or if we look on the right, the curve would go up, more to the right side, the higher the numbers, so not normal. Here's another example, normal distribution, and now it's greater on the left than the right. So here's just a few more for you to look at. You can again tell the left is your normal distribution, and notice the scores are higher on the right-hand side, which we call the height of the students. The left again is your normal distribution. The one on the right, you kind of notice it kind of goes up and down for your body mass. All right, so what we're going to talk about next is standard deviation. We've already introduced this to you. It's how much it deviates from the mean. So remember, the mean is your add up all the items and divide by your total to find your essentially average. The shape of a normal distribution is completely described by two numbers, the mean and its standard deviation. The mean is at the center of the symmetry of the normal curve. The standard deviation is the distance from the center to the change of the curvature. So I'm not going to go through really how to find these values. If you'd like to read that and pause, you can. Here's an example of height of women, and we notice there are some lines here already drawn, and we talk about box plots and quartiles. The middle here is what we call the mean. So the mean is 64.5. So very, very close to 64. Then the standard deviation is 2.5. So we would say one standard deviation would go 2.5 on the right, 2 standard deviations, 3 standard deviations. Again, you're not having to take any notes right now. Now, this is what we're going to focus on, is the normal distribution, which we call the 68, 95, 99.7. Between 3 standard deviations to the left and to the right, 99.7% of our data falls in there. Then, if we go between 2 standard deviations, it gets a little smaller. Not much, still 95% of our data falls. Then we go to 1 standard deviation in the left and the right. Now we're a little bit smaller, we're at 68%. So what we're going to do, if you look below here, this is the thing we're going to focus on, these percentages. And you're going to see this throughout our examples. So when you're at plus 1 standard deviation or minus 1 standard deviation, anything that falls in this category here or in this category here would be 34% of the data. And then same thing goes when you have plus 2 or minus 2 will be 13.5. And then at plus 3 or my, oops. My minus 3 here. I didn't talk about my 2. And then anything above minus 3 would be 1.5% and 0.15%.